Good morning, students. Today we are going to discuss about the concept of phase and the phase difference. So the phase of any alternating quantity is defined as the phase of any alternating quantity is defined as at any instant the angle phi traveled by the phasor representing that AC quantity up to the instant of consideration measured from the reference. For example, if you take a complete rotation of a vector. Now the phasor is nothing but what is the distance traveled by this vector is nothing but the phase. So the phasor is nothing but it is a vector that is used to represent the sinusoidal function. It rotates about the origin with the angular speed omega. So for example, so let us take a vector rotating. So now let us say the vector which is traveled from the reference axis to here. Then what is the distance traveled by this phasor? If you transform this here, now this is called as the phase of an AC quantity, right? So now let us take, this is the maximum current. So in this way, what is the distance traveled by the AC quantity is nothing but the phase, right? Now let us take a phasor which is having the magnitude as well as the time period rotating about its axis. So let us take the angle traveled by this is phi, which is equals to 0. Now when the phase of an AC quantity is 0, it is a pure sinusoidal quantity having the instantaneous value 0 at t equal to 0. Now let us consider the AC quantity, right? So this may be, let us take it is V, right? So now let us take E of t equal to Em sine omega t. Then when phi is equals to 0, now what is a phasor diagram we can represent? Here is nothing but this is a phasor diagram. So which representing the 0 phase, right? So simply now what is meant by the positive phase? So the positive phase is nothing but let us take E equal to Em sine omega t plus phi. Now the positive phase is phi. Now how you define the positive phase of any AC quantity? Now in any quantity which is having a positive value at t equal to 0 is having a positive phase, right? So now if you see here, now this is having the positive value at t equal to 0. Now this is called as the positive phase. So this may be V, that is V of t. So now how you represent the positive phase? The positive phase is plus phi. So now E equal to Em sine omega t plus phi. Now how you define the negative phase? So the negative phase is nothing but any quantity which is having the negative value at t equal to 0 is called as the negative phase. Now let us take a t equal to 0. What is the magnitude we have here? Negative. So this will be V of t. So now the negative phase we can represent as E equal to Em sine omega t minus phi. So which is called as the negative phase, right? So now the positive phase is nothing but when the phase of an AC quantity is positive means that quantity is having the some positive instantaneous value, that is this one, at t equal to 0. Similarly, the negative phase is nothing but the phase of an AC quantity is negative, it means that the quantity is having some negative value at t equal to 0. Now this is called as the negative phase. Now what is meant by the phase difference? The difference between the phase of two AC quantities is called as the phase difference. The phase difference is nothing but the difference between the phases of two AC quantities. So let us take E equal to Em sin omega t and I equal to Im sin omega t minus phi. Now, so if you compare this, then what is the conditions we should have here? The individual phase of an AC quantity is always referred with the positive x-axis. This is very important. And the frequency of all the AC quantities must be same. Okay, so now when you want to compare the AC quantities, the frequency must be same. Now the phasors are assumed to be rotated in anti-clockwise direction. This is very important. So always the phasors are rotated in anti-clockwise direction. This is very important. Now always the phasor can be considered, the individual phase is always referred with respect to the positive x direction, right? So the phasors which are ahead in anti-clockwise direction with respect to the reference phasor are said to be leading, and the phasors which are backward is called as the lagging phasors, right? So I repeat once again, the phasors which are ahead in anti-clockwise direction with respect to the reference phasor are said to be leading with respect to reference, and the phasors which are behind are said to be lagging. Now, if you take these two phasors here, now we can say that I is said to be lag by angle phi. Similarly, if I take I equal to Im sin omega t plus phi, now I is said to be lead by an angle phi. Right. So suppose if I equal to Im sin omega t, then so the I is said to be in phase. Right. So finally, if I write I equal to Im sin omega t plus or minus phi, then plus is representing the leading angle and the minus is representing the lagging angle, right? Now this is about the phase difference, right? So now suppose if I take any phasor, let us take z is equals to x plus jy. Now this is called as the rectangular form, and z is equals to r with an angle of theta, which is called as the polar form, and z is equals to r cos theta plus j into r sin theta is called as the trigonometric form, and z is equals to r into e power j theta is called as the exponential form. Now let us take the two phasors v1 of t equal to 10 sin 2t plus 45 and v2 of t is equals to 10 sin 2t minus 15 degrees, right? Now what is the phase difference between these two? The phase difference is nothing but 45 minus 15, which is nothing but 60 degrees. Now So when you see this, V1 of t leads, V1 of t leads V2 of t by how much? 60 degrees. Right. Now let us take the three phasors V1, V2 and V3. Now let us take this is 60 degrees and this is 30 degrees. Right. So now what we can say here, V1 and V2. What is the phase difference between V1 and V2? The phase difference between V1 and V2 is 30 degrees, and the phase difference between V1 and V3 is 60 degrees, right? And if we take V1 is the reference phasor, now how you define this? V1 is the reference phasor. Now V2 lags V1 by 30 degrees. So V2 lags V1 by 30 degrees. Now V3 leads V1 by 60 degrees. Now always the lagging phasor is rotates in clockwise and the leading phasor is rotates in anti-clockwise. Now if you take V1 is the reference here, so V3 is anti-clockwise, means which is traveling first, so V3 is traveling first. Now if you take V1 is a reference, so now V1 after V1, V2 is reaching, right? So now V2 lags V1 by 30 and V3 leads V1 by 30, and V3 is a is rotating in anti-clockwise. Okay, now so now V2 if you take, this is downward, so now you can say that V2 lags V1 by 30 degrees. Now, the next one is very important. There is the term in the AC circuits, we have the J operator or the J notation. So, J operator or the J notation is very important. Now, how you define the J operator or J notation? It is a quantity when it acts on any phasor, the phasor will turns into 90 degrees in anti-clockwise direction. Say for example, if I take a vector A with an angle of 0. Now if I operate J on A, so what you will get? So the J is operated on A, so now you can get here J A, right? So now it takes 90 degrees rotation, right? So similarly if I operate J one more time on JA, so now it becomes J square A, means one more time I operated J on JA, so it becomes J square A, means 180 degrees it takes a rotation. Similarly if I operate one more time, now it becomes J cube A, and so now if I operate one more time J cube on J, so what you will get? J power 4A, right? So now you can say that if I write A angle 0, now this will be shifted to A with an angle of 90, right? And next it is shifted to A with an angle of 180, and next it is shifted to A with an angle of 270, and next it is shifted to A with an angle of 360 degrees, right? Or you can simply say that J is equals to under root minus 1 that is 1 with an angle of 90, and j square is equals to minus 1, that is 1 with an angle of 180 degrees, and j cube. So j cube is j square into j. So what you get, minus j, that is 1 with an angle of 270 degrees, and j power 4 means j square into j square. So what you will get, 1, that is 1 with an angle of 360 degrees. Means what is the importance? So if you operate j on any vector, so that vector takes a 90 degrees rotation in anti-clockwise direction. Right. Next, now we are going to discuss about the basic definitions. Right. Now the impedance. The impedance in a AC circuit. The impedance in a AC circuit is denoted with Z. So now how you define the impedance? It is the total opposition offered by the AC circuit for the flow of current through. It is called the impedance. Right. So now you can write the impedance as R plus R minus Jx. Right. Or you can also write the impedance as J is equals to V with an angle of theta 1 by I with an angle of theta 2. The ratio of phasor voltage to the phasor current is also called as the impedance, right? So suppose if I want the magnitude of Z, now how I write, R square plus X square, right? And the phase angle if I want means phi is equals to tan inverse X by R, right? Now what are the units? The units are ohms only, right? Now the reactance. So now the reactance is denoted with X. So now how you define the reactance? The reactance is nothing but the opposition offered by the reactive components, that is inductor or the capacitor, in an AC circuit for the flow of current through it is called reactance, right? So now this imaginary part of the impedance is simply the reactance. Now the inductive reactance is called as XL, which is written as 2 pi FL, and the capacitive reactance is called as 1 by 2 pi Fc. Now you can also write this as 1 by omega C, because omega equal to 2 pi F. Now this can be written as omega L. So simply the reactance is nothing but the opposition offered by the reactive components, that is inductor or the capacitor, in an AC circuit for the flow of current through it is called the reactance. Now what are the units? There is no change in the units. The units are ohms only. Right. Similarly, the admittance. So the admittance is nothing but the reciprocal of the impedance. So simply the admittance is Y can be written as 1 by Z. That is the reciprocal of impedance. That is 1 by R plus R minus Jx. Right. So suppose if I want the magnitude, so R by R square plus X square minus R plus Jx by R square plus X square. So you can write this as G minus R plus JB, where G is called as the conductance, that is equals to R by R square plus X square, and B is called as the susceptance, which is equals to Jx by R square plus X square, right? Minus R plus. Now the susceptance is nothing but simply the imaginary part of the admittance, right? So the minus is represented for the inductive susceptance, and plus is represented for the capacitive susceptance. And similarly, what is the conductance? The conductance is simply the real part of the admittance. Now the units are mhos, right? So or you can also write as ohm inverse. Next, the real power or the reactive power. First we will discuss about the real power or the true power or the active power or the average power, and this can be also called as the watt power or watt full power. Now the real power is nothing but the product of RMS value of voltage and the current with the cosine of the angle between them is called the active power. That is P is equals to VI cos phi. Now the units are watts. Now, or the power in an AC circuit can be defined as the product of RMS value of voltage and the active component of the current is also called as the active power. Now next, the reactive power. The reactive power is also called as the wattless power. Now how you define the reactive power? The reactive power is notated with Q, the product of RMS value of voltage and current with the sign of the angle between them is called as the reactive power. That is Q is equals to VI sin phi. The units are vars. Now the average power delivered to the reactive elements is always 0, or you can also write the reactive power as IRMS square into XL, that is IRMS square into Z sin phi. The average power, you can also write the average power as P is equals to 1 by T integral 0 to T P of T dt. The units for the reactive power is volt ampere reactive. And you can also define the reactive power as the power in an AC circuit can be defined as the product of RMS value of voltage and the reactive component of the current is called the reactive power Q. Now the next one is nothing but the apparent power. The apparent power is nothing but, yes, the apparent power is simply the apparent power, yes, is equals to the product of RMS value of the voltage and the RMS value of the current. So simply you can write under root P square plus Q square, or S can be also written as P plus or minus JQ. Then the power factor. So the power factor plays a very important role. Now how we define the power factor? The power factor is nothing but the cosine of the angle between the voltage phasor to the current phasor in an AC circuit is called as the power factor, and we denote the power factor with cos phi. Right. Now if you take a resistive load, cos phi is equals to 1. Right. That is V is in phase with I, and the inductive load, the inductive load current lags the voltage by an angle phi. Now if you take V is the reference, now I lags, right. So now you can say that I is downwards, right. So means I is in clockwise direction, right. Now if you take V is a reference, so I is downwards, means it is clockwise direction, so you can say I lags V. Now similarly the capacitive load, so the capacitive load is the current leads the voltage, right. Now if you say V is the reference, now I leads, right. Now if you say here I is rotates in anti-clockwise direction, means I is travels before V. Right, so now you can say that I leads V. Now the next one is the power triangle. So the power triangle is a geometrical representation of the apparent power, active power and the reactive power. Now if you take a inductive load, so we know that V and I, so I lags V. So now the power triangle, you can take Vi cos phi as P and this is Vi sin phi and this is the apparent power Vi. So now this is you can write as Q and this is you can write as P. Right? Now this is a power triangle. So S you can write as under root P square plus Q square. So which is equals to V into I. So similarly this is for inductive load. Now for a capacitive load we know that I leads V. Now this is phi, right? So now how you take the power triangle? So this is Vi cos phi and this is Vi sin phi. Now the resultant is the apparent power S is equals to under root P square plus Q square which is equals to V into I. Now this is phi. Right. So now this is a power triangle for a capacitive load. Now finally we can define the complex power. The complex power we can simply write as V into I conjugate. So which can be written as P minus JQ. No. Now the analysis of single phase AC circuits. Now, so let us take AC through a pure resistance. Now let us take a AC is supplied to the pure resistor. Now what is the performance of the circuit? We are going to see. So V of t is equals to Vm sin omega t. Let us take, right. So now this is R. So now let us take the current flowing in the circuit is I of t, right. So now according to Ohm's law we can write I of t is equals to V of t by R. So which is equals to Vm sin omega t by R. So which is equals to Im sin omega t where Im equal to Vm by R. Now if you compare these two, now compare this equation with the standard equation Im sin omega t plus or minus phi, right. So let us take this is equation 1 and equation 2. Now this is a standard equation, right. Now compare equation 1 and equation 2. Now if you compare 1 and 2, so phi is equals to 0 degrees here. Then what is the maximum value of the current? The maximum value of the current is Vm by R, right. Now phi is equals to 0 represents the voltage and current are in phase. Right, so now you can write, if you take this is V of t, now, so I is in phase. Now you can say this is I of t, which is equals to Im sine omega t. Right. And the phasor diagram, how you write? I of t is in phase with V of t. So now this is a phasor diagram. Right? Now the instantaneous power, how you define? The instantaneous power is nothing but the product of instantaneous voltage and the instantaneous current. That is Vm sine omega t multiplied by Im sine omega t. So what you will get? Vm Im by 2 sine square omega t. So sine square omega t, so Vm sine omega t into Im sine omega t. So that is Vm Im sine square omega t. So you can write as Vm Im by 2 1 minus cos 2 omega t. So therefore the instantaneous power, so P instantaneous, which is equals to Vm Im by 2 minus Vm Im by 2 cos 2 omega t. Now if you take a average power, now if you want the average power, so 1 by t integral 0 to t p of t dt. Now you have to integrate the instantaneous power over t. So then you will get the average power. So now the average power you can write as P average is equals to integral 0 to 2 pi Vm Im by 2 1 minus cos 2 omega t by 2 pi. So you can take Vm Im by 4 pi integral 0 to 2 pi 1 of d of omega t minus integral 0 to 2 pi cos 2 omega t d of omega t. Right. So what you'll get? Vm Im by 4 pi omega t, apply the limits 0 to 2 pi minus, so integration of cos sine 2 omega t by 2, apply the limits 0 to 2. So what you'll get? So which is equals to Vm Im by 4 pi, so 2 pi minus 0. So what you'll get? Vm Im by 2. So which can be written as Vm by root 2, Im by root 2. Now Vm by root 2 we can write as Vrms, Im by root 2 we can write as Irms. So therefore for a pure resistive circuit, the average power we can write as V into I, that is Vrms into Irms.